Under the Lab Coat, the podcast that undresses scientists. I'm Elodie Chabrol and I can't wait to take you with me to meet the humans behind the research. We will of course talk a little bit about science, but we will mostly talk about them. Welcome in this new episode of Under the Lab Coat. Today I have the immense pleasure of welcoming Francesca Fragkoudi, astrophysicist in Durham. Hi Francesca.
Hi Elodie, thanks for having me.
I'm really happy because we know each other for quite a few years now. And I always thought you would be really good for this podcast, and since I'm relaunching them, I'm so happy you're part of the guests. So can't wait to hear all your stories.
Oh, thank you.
We are always starting with the research. So can you tell us, I said astrophysicist, which means basically everything and nothing at the same time, because that can be on so many subjects. So what are you working on?
Yeah, so I would probably describe myself as a theoretical astrophysicist. So there's kind of broadly two kinds of astrophysicists. So there's the observational astrophysicists. So those are what I guess people commonly think of as the astronomers, the astrophysicists, the people that look through telescopes and collect data of the universe. And then on the other side, there's like a little bit of competition between the two sides, I would say. There's the observational and the theoretical ones.
Yeah.
So I'm a theoretical astrophysicist, which is I basically make models or theories to try and interpret what we see in the universe.
Okay, and you're working especially on dark matters, right?
Yes, so my research is around galaxies and the interplay between galaxies and dark matter. So galaxies, they're basically a accumulation of stars and gas and dust and dark matter. And one way you can maybe think of galaxies as an analogy is that you can think of them like cities. So the same way you have, and you can think of them as like cities at night. If you look at a city from an airplane as you're traveling over the city at night, you'll see a lot of little bright stars, and those are, let's say, the houses in that city, right? And so you can think of each of those houses like a star in a galaxy. But there's also a lot of the dark stuff that's connecting all of the houses between them, so that you can think of like the dark matter, like the roads and the bridges and everything that's connecting all of these little lights to each other. Yeah. And a bit like cities can change in time, so they grow, they can kind of engulf other little villages around them and become bigger and bigger. So also galaxies can change throughout their lifetime and become engulf other galaxies and become bigger and change in time.
Wow, okay. And now we can see you're also a science communicator. Definitely, when you explain your research. Okay, and so you're doing models on your computer?
Well, I don't do models on my computer. So the models we do are on supercomputers.
Okay.
Basically, galaxies, they do change in time. As I was saying, they change, they grow, but the time scales over which they change are like billions of years. Yeah. So we don't see this change in our human lifetimes. Yeah. But if you were like if you lived for billions of years, you would see that the universe is very dynamic, it's changing. And so what we do to try and study this is we actually create models of the universe in our computers to try and understand how galaxies might change throughout billions of years and how we end up with the galaxies that we see in the universe today, because there are essentially billions of galaxies in the universe. Each one of them is different, but they also have some similarities between them sometimes. And so that can tell you something about how they formed from the very early universe to today. Okay. And so we create these computer simulations on basically supercomputers that crunch the numbers and do lots of calculations for us to create these kind of little model universes where we can study galaxies.
And when you say, it's a very naive question, be careful, be ready. When you say models, is it like images or calculations? Like when you say we're having models of the galaxies,
right?
What is the model? Like if I close my eyes and you had to describe me exactly what it is it like numbers on the computer that represents the different stars and the different galaxies, or is it actual like kind of images?
Well, I guess it's kind of both. So what you would do is you start with some initial, like with any physics problem, you start with some initial conditions, so some initial assumptions about what things were like in the beginning. And then we basically have equations. So things like, how does gravity behave and how does gravity affect stuff? Okay. And then, you tell the computer, okay, crunch the numbers, solve these equations, and then you get out at the other end, you get basically the final product, which would be, like galaxies distributed in a little model universe today, but you can make images from that, and they represent the stars, the dark matter, where they are distributed in space, that kind of thing. Yeah.
Okay, super interesting. I think I could ask you so many questions like for this entire podcast. So I'm going to stop there. Thank you for explaining your research. I have this little tradition, since it's called Under the Lab Coat. Do you have a lab coat in the lab?
No, unfortunately, we're very boring. We just wear normal clothes. No fun lab coats like biologists.
Yeah, it's not boring. Well, for us, to be honest, it's more to protect ourselves, and most of the time they become really dirty. When I was in PhD, every time I was opening a box that was closed with a tape, I used to take the tape because it was like gluing on my gloves and everything, and put it on my coat, and then you could see how much experiments I've been doing that week, because I had some kind of bump of tape, right, because I was always putting it at the same place on my lab coat, and it looked really bad, and people were like, come on. So I'm not saying I don't think it's boring. I think it's quite nice. Everyone's wearing whatever, your real clothes. But that was the little tradition, to know if you have a lab coat.
Mm-hmm. So it's not quite as glamorous as we imagine, like the lab coat.
So not glamorous, especially in the lab. They often have it in sizes that are really not fitting you. So, you have to roll your sleeves because they are way too big. Sometimes they are very, very long as well, because they just order whatever size they have, or some labs, they just have some, that are not necessarily yours. So it's so not glamorous. So I think it's much better if you don't have any lab coat, to be honest. So now we're going to remove this non-lab coat, so virtual lab coats, to talk about you. Mm-hmm. So how did you decide to do research first and to be astrophysicist? Is it something like, were you interested in the stars when you were a kid? Is it something that, come from that, or did it come later in life?
Well, I think I was always quite interested in understanding like how things work and how the world works. And I was interested probably in kind of different scales of things. So like, I remember even when I was a kid, I think, my mom had got me a book about science and astronomy, and it had a picture on it with a galaxy, and it was talking about how, you have these billions of stars in the galaxy, and each star is a sun, like our sun. Yeah. And so it was this like beautiful galaxy, and then there was like a little point, and like one tiny little point in the galaxy, and it was saying, the Earth and the whole solar system is smaller than this tiny point. And that just like blew my mind that was even possible. Yeah. And I think I was always very curious about how the world works. So when I was, even when I was quite young, I used to do these little thought experiments where I had read in one of these books, I had read that the universe might be infinite, but we don't know. And so that kind of played, I think it's just so difficult I think it's impossible to visualize infinity. Like we can't, right? Yeah. It's just humanly impossible. What does it even mean? Yeah. So I used to do this little thought experiment where I would fly in my head to the end of the universe and just like keep, fly through like galaxies and stars and try and reach the edge of the universe. And then I would be like, okay, well, I've reached the edge of the universe. And then I was like, but how can there be an edge? There has to be something outside it. So then I would be like, okay, now we keep going. And I'd be like, okay, but it can't go on forever. It has to end somewhere. And so then I would again, be like, okay, I have to reach the end now. Yeah. And then I would, keep doing this little repetitive kind of little exercise of trying to understand what it might mean for something to be infinite or not, because I just couldn't wrap my head around it. So I would try to kind of visualize that. Yeah. Also on the opposite side of things, I used to like try and imagine cutting things into smaller and smaller pieces until you could get like an atom, or like, I think I had read about like atoms or something, and I was trying to understand these tiny little pieces of matter, and I was like imagining trying to cut things and being like, okay, at some point it has to stop. So yeah, I think I was really fascinated by those kinds of ideas from quite a young age. But I went through a phase where I wanted to be like an explorer and explore, the jungles of Brazil or that kind of thing. Or
this is nice. You're kind of an explorer, though.
A little bit, I guess. Yeah, like an explorer of
the universe.
Yeah. Well, a simulated universe.
Yeah, exactly.
A fake universe.
Yeah, you're an explorer of the fake universe. Man, it doesn't sound as good though. Yeah. So when you were in school, did you like science? Was it then something that you wanted to do?
Yeah, I definitely liked science quite early on. And I had a great, actually, literature teacher who saw that I really liked science. And she gave me one of the first kind of popular science books that I read. So yeah, I did really like science. I was good at like things like maths and physics. Like I did well at those kinds of things.
You grew up in Cyprus, right?
I grew up in Cyprus. Yeah, I grew up in Cyprus, and yeah, it was quite. I would say we were taught these things in a quite dry way, but I still enjoyed them. And I think through kind of books and stuff, I also got to see the more fun aspects of science. There wasn't a lot of science communication going on in Cyprus when I was a kid. So it wasn't, but I think through books and stuff that gave me kind of the fuel of like, oh, this is really interesting and fascinating.
It's great that actually a literature teacher gave you a science book.
Yeah, no, exactly. I don't know, I don't know if I would have gone down that path if it wasn't for her. So kudos to great teachers and literature teachers promoting the sciences as well.
Exactly, because it feels almost like competitive fields, where, you don't want to do literature, so you do science. This is not my problem anymore, but this is amazing to find your book.
Maybe it's that I was so bad at literature. She was like, let's get her far away from this field as possible.
Good riddance. Take this science book and please leave. Okay, so then high school. So science, you were good at physics and math, and then you went to university thinking to do astrophysics.
No, I think at that age I was more interested in theoretical physics, theoretical particle physics. So I was much more interested in the very, very small, I think.
Cutting stuff into
tiny, yeah, exactly. Yeah, so I went to university and I was studying physics. I actually was doing a physics and philosophy joint degree, both of them together. And then after my second year, I was like, okay, I'm definitely more into the physics. So I left philosophy. And then I think what happened was that I felt like the theoretical physics or theoretical kind of particle physics was very abstract. It was very mathematical, extremely mathematical. And yeah, I always laugh because I said I wanted to do something more tangible. So I did astrophysics because it was seemed less abstract than particle physics. You could really, see the things you were studying. There was something about that drew me to it, that I could really see those objects and try and understand, see them through a telescope and then try and understand how those objects were the way they were, how we started from kind of the Big Bang to end up having these beautiful objects called galaxies in the sky.
So during university, then you switched to astrophysics. What happened? And how did you decide to do research as well?
So I finished my degree in physics, and then I went on and did a master's in astrophysics and cosmology. So I did my undergraduate in the UK, and then I went to Spain to do my master's.
Whoa.
Yeah, that was where I kind of really got into I felt like I would like it, and then I did this more seriously, and I really enjoyed the astrophysics aspects and learning about cosmology, learning about the universe, learning things like general relativity and how the nitty-gritty of general relativity and black holes and all that stuff just seemed so fascinating and fun to me. It was also where I really decided that I did not want to be an observational astrophysicist, because we got the chance to actually go to telescopes and do observing, and you had to stay awake all night and sit at be very, very meticulous in how you observe things. And I was like, okay, no, I actually like the theory part a lot more, thinking about it and calculating stuff.
So then you did a PhD after that?
Well, after I did my master's, I took a year out and I went and I traveled around a little bit in South America, which was a really beautiful experience. And then after that, I did a PhD in France.
Oh, where?
In Marseille, in the south of France. So beautiful Marseille. And so that's where I really kind of got into exactly what I work on nowadays, which is more thinking about galaxies, thinking about how galaxies move. So what we call the dynamics of galaxies, thinking more about dark matter and why we think dark matter is there, even though it's something we can't see. And basically because of the influence it has on all of the stuff that we do see, the gravitational influence that it has on all the stuff that we do see, and thinking about all that stuff.
Amazing. So this is how you basically started research. And then because sometimes people do a PhD and then they don't continue in research, but then you decided to continue research.
I applied for what we call postdocs, right, which are these short-term contracts that you do after your PhD, but before maybe you have a permanent position at a university or a research institute. And so I applied for postdoc, and I got one after my PhD, and so I was like, okay, I'll keep doing this and see how it goes for a while longer. I was still having a lot of fun with it, and also I didn't really know at that point. I was like, I'm not sure what else I would like to do, and then which was interesting because as I then started doing more science communication, which is also how I met you, I also started to think more about things like, maybe I would like to go more into the educational aspect or the science communication aspects. But I think I always kept finding research quite fun and challenging. And there were many different times where I did think about, quitting, because also it can be challenging also in negative ways. But you kind of keep going, and I kept finding things that kept wanting me to keep going, and more questions that I wanted to research and stuff.
Fueling your brain.
Yeah, exactly.
And so your postdoc, you did it in Germany, right?
Well, I did a first postdoc in Paris for 2 years, and then I went to Germany. I did 1.5 postdoc in Germany, and then now I'm in the UK again at a university there. At the University of Durham. Yes. Yeah.
So I have two things that I wanted to bounce back on. You said you liked science communication and educational side as well, but you have a job as a teacher researcher, right?
Yeah, researcher and research and education as well. Yeah, both of those.
So it's great because being a researcher, you can do science communication, but you can also teach students. So you have everything at your job, right?
Yeah. It's I can do everything and all things that I enjoy. Sometimes it's too much because there's not enough time in 24 hours. But it's great that I get to do all of those. Yeah.
And also another question, because you started in Cyprus, then Spain, then France, then Germany, then UK, and I might miss one. No, I think I didn't miss anyone.
No, I think you've got all of them, yeah.
Yeah. Was it something that you wanted to travel so much? Was it needed because you went to labs that were only in that place? Because you traveled a lot.
Yes. I think that the career is something that often lends itself to traveling. So you don't absolutely necessarily 100% have to do it, but it's a lot easier if you are flexible, because you get to work with a lot of different groups and create a really, broad network. And so that's really good for your career, I think. And also just, jobs will pop up at different places that you might be the right person for it. And so if you're flexible to move, then it just makes it easier. For me personally, I love traveling, and I wanted to leave Cyprus. I was so ready to leave when I was 18. I was like, I want to see the world. So for me, it was always a huge bonus of the job that I got to travel a lot. There were times, probably around just before I got this permanent job, where I was also quite ready to stop moving every 2-3 years, because it can also be tiring. But I definitely think that it was good for me that I enjoyed traveling in the early stages, because it meant that it wasn't a bad thing for me that I had to move every 3 years for a new job. It was also something that I was really excited about and I enjoyed. Yeah, it can also be something that I think can be constraining for people who have to stay in the same place, right?
Yeah. No, that's why I was asking, because you moved really a lot, even during your studies. So I was quite amazed by the number of countries and cities that you've done. Okay, so this is how you became a researcher. The question, so you're an astrophysicist. It's quite a masculine domain, I think.
It's definitely quite there's more men in the field, definitely, yes.
Yeah, so how is it to be a woman in astrophysics?
Well, I feel like there are extra challenges that come with being a woman in STEM that I think men don't have to deal with, because I think the the system or the structure of academia has basically been built around men. And so like there are a lot of things that make it more challenging for women in academia. So even things like, you know, this assumption that it needs to be your one and only passion, and like there's no working hours, you work whenever is needed. That's not very compatible with things like, you know, if you have any caring responsibilities, which usually fall on women. Or, you know, the fact that you have to move a lot. I mean, as we were saying, like I very much enjoyed moving, but I think that can be, again, challenging if you have kids or a partner that needs to move with you. So I think there's additional challenges faced by women also. I think, you know, nowadays things seem quite equal in the sense that we see more women nowadays. We see more women nowadays in science and in STEM subjects than we did maybe, I guess, when we were growing up. But that's a very recent thing, right? So I think there's a lot of preconceptions that are changing, but I think we're not quite there where...
Slow.
I think it's still slow. And there's, if you look at the numbers, the number of women in STEM, especially in more senior roles, is still extremely, extremely low.
Yeah. And especially physics, right? Because in biology it's reversed, because in all the junior position, let's say PhDs and postdoc, PhDs, you have tons of women. Like it's actually the majority. Postdoc, a bit less. And PI, so when you're a researcher, even less. And then, you know, directors and everything, even less. So it's the contrary. Like at the beginning, they are all there. You're the majority. And then the more you go, the more you're like, where are you? You know, like what happened? Yeah. And so that's that. But in physics, I think from the beginning, you're not that many, right?
Yeah, I think there's still fewer women in physics already at the kind of first step, let's say even in undergraduate degrees. But that difference becomes accentuated. So you still have this scissors diagram, right, where you have fewer and fewer women as you go to higher levels, and more percentage of men as you go to the higher levels. Yeah, so we're still, you know, losing women as they move along their career, and it's still I think it's still very challenging, often because society puts also more pressure on women to, you know, do it all and have the kids and do this and do that. And whereas I think for men, it's like maybe a little bit like more, they just have more time. I don't know. They're not as stressed. I don't know. Yeah, I think, but I also have to say that I've had a lot of very good female mentors that have supported me. And I think that was a big thing that helped me see that there is a pathway to that career, and that is something that is possible and that I can kind of look up to. So I think I've been really lucky in that way.
Yeah, it's definitely important. Thank you for sharing that experience with me. And also thank you for being a model, you know, being on the podcast and explaining your background and your life as a scientist. Speaking of which, we talked about science communication a bit. It's how we met. So we met at Falling Walls Engage the first year. So I'm going to put the link for Falling Walls if you want. The idea of Engage is it's a pitch competition, which has nothing... It's not really a competition. Like we are competing, but it really felt like we were just friends meeting, basically.
We're all winning.
Yeah, exactly. Well, you won, which everyone was relieved because you were the one presenting and we could go out and party.
That's true, yeah.
But yeah, it was that. So Falling Walls Engage is really about bringing science communicators from all over the world that have initiatives that are changing, you know, science and society for the best. And yours, to be honest, when I presented and I heard all the amazing ones, and yours in particular, I was like, I hope I'm not going to win, because I would feel really bad if I was winning. And I was really hoping yours would win.
Oh.
So I'm going to probably not pronounce it right, but it's Columba Hypatia project, right?
Yes.
Astronomy for Peace.
Yes.
So what is it exactly, and are you still doing it?
Yeah, so the Columba Hypatia project was something that started so I started it after I'd finished my PhD in around 2016, 17. And the project basically uses this idea of how astronomy can be used as a unifying force for people and to bring people together. So it kind of comes from the Astronomy for Peace, as the name suggests. And as I said before, as you were mentioning, I grew up in Cyprus, and Cyprus is a country where it's in a post-conflict state. You have like two communities of Cyprus that are living separately. And I had the opportunity to see through other science outreach initiatives. In particular, I was a member of this beautiful initiative called Galileo Mobile that brings astronomy to communities around the world. And I had participated in some of their projects. And in particular, I had participated in one of their projects that went to Peru and to very rural areas of Peru. And I saw how powerful astronomy is in bringing together people from very different backgrounds and very different contexts. I guess a little bit like Falling Walls, like you're all there together for like with a common passion, I guess. And like, so we were doing astronomy with all these kids and from like very different backgrounds, and it just created this beautiful feeling of unity. Also, the motto of Galileo Mobile is "Under the Same Sky." And so that started building this idea in my head of, what if we used astronomy also in somewhere like Cyprus, where you have this post-conflict state where people aren't really talking to each other? So that was how the idea to start doing something like this in Cyprus started. So basically, we started bringing together children from the Greek Cypriot and the Turkish Cypriot communities together and doing astronomy activities with them. And so they got to also, kind of break down these preconceptions and barriers that they had about each other. And astronomy was used as kind of this tool of promoting global citizenship, and that we're all under the same sky, and that we're actually not that different in the end.
Amazing. Are you still doing that?
Well,
is it still active?
It's not. No, it's died down a little bit because basically with COVID-19, the crossings between the two sides of the island were closed for a very long time, and also just because of political reasons that maybe we don't want to go into, it's been more challenging to keep carrying out the project. Because it's quite difficult to bring kids from schools from both sides of the island together. But I do have a new project that I'm working on at the moment, which is called Stars of Peace, which is going to involve bringing teenagers from the two communities in Cyprus to Durham for summer schools, STEM summer schools, where they will again get to meet each other. And also it's aimed mainly at girls. So the idea is to kind of empower women to be future leaders of STEM and also of their communities.
Amazing. So this is going to be next summer? No.
That is the plan. Yes, this is to start next summer. So it's kind of under the same umbrella of Astronomy for Peace, but just logistically, it's I'm hoping it will be a bit easier to do.
A bit easier and also a bit more advanced in astrophysics, maybe?
Yes, exactly.
Okay. And for older?
It will be for older girls. So the Columba project mainly targeted primary school children. We did have some activities for youth, but it was mainly primary school children that we were aiming the activities at, whereas Stars of Peace will be basically teenagers in the last few years of school before they go to university.
Amazing. So this is to make them leader in STEM, you said? So STEM, science, technology, engineering and math, right?
Yes, exactly.
Just in case someone doesn't know. Amazing. So really strong in science communication. Do you do other things in science communication?
I mean, I do bits and bobs here at the university. We have a mobile planetarium that we take around schools in the northeast of England. So that's been really fun as well.
Amazing.
Because the northeast is a region that has been quite disadvantaged socioeconomically. So we try and kind of get kids also interested in STEM and that kind of thing.
This is really cool. I'm going to put your LinkedIn profile and your Twitter account as well.
Yeah, great.
And so people can follow what you do and follow the stories as well and see all the research and the science communication that you do.
No pressure.
So, no pressure. We're watching you. So usually I talk about the hobbies, but for you, is science communication, do you see it as a job or as a hobby?
I wouldn't say I see it as a hobby because it takes a lot of effort, and I guess hobbies can take effort as well. No, I guess I see it as part of my role of I think it's important also for researchers to do science communication. Not everyone has to do it, but it's something that I enjoy doing, and so I think I see it, I guess more as part of my job. the good fun part of it.
Yeah, the good fun part of the job.
Yeah.
So we talked about science communication, science, obviously research, your work. It doesn't give you much time outside of that because you also do some teaching. But do you have some hobbies that you do maybe during the evenings or the weekends?
Yeah, so I'm one of those people who likes to try a lot of different things and kind of switches between things. So I like to get outside, outdoors and stay active. So I really enjoy hiking and going for walks now in the rainy English countryside.
Yeah.
But yeah, when I was in Germany, I loved skiing also in the Alps and hiking in the Alps. That was wonderful.
That was very different from the UK, probably.
Yes. Whenever people talk about hiking in the UK and they say, "Oh, we went to the mountains," my partner is always like, "They're not mountains; they're hills."
They're hills.
Yeah.
Sometimes very big hills, but yeah. So probably your hobbies are depending on, because you've lived in different countries. So obviously, if you live somewhere where it's really hot, like Marseille, you cannot do the same things that if you're in the UK. So it's probably depending on like where you live as well. Do you have some that you're still doing?
Yeah, so I do. I mean, I still go out hiking around here and still try and do a bit of running and that kind of thing. Yeah, I also enjoy doing kind of dancing and team sports. So nowadays I've started since moving to Durham. I started something called roller derby.
Oh,
yes, which is a fun kind of team sport.
Yeah, can you explain a bit?
So it's a sport where you go around on skates. The best way I've heard it described is it's a combination of skating and rugby.
Okay.
So you have to kind of score points against the other team. And so you run around on a track on your roller skates and get hit and hit people while you're trying to score points. Or well, not hard.
Yeah, but still, that must be quite hard to do, and you must be full of bruises after that.
Yeah, so I'm still very much a newbie, so I'm still kind of getting used to the game. So I'm not in the kind of brutal. So the advanced team, they're just very hardcore and badass.
Yeah.
I'm still learning how to get used to being on skates and that kind of thing. But it's very fun. It's a very fun sport.
Why did you pick that?
I really like doing sports that involve other people, like team sports or group sports. So I used to do a lot of capoeira when I was in Barcelona and then in Marseille. It's like a very kind of group activity. There's singing and music and you play with other people. And I couldn't find a kind of a big group that did the same style of capoeira here. That is what I used to do. Yeah, I wanted to try something that was kind of a team sport that also involved, I don't know, some movement. So like I like the idea of the roller skating and kind of the creativity of it.
Yeah, it's really cool. And it's a really cool sport. I've seen a bit of it. I was like, I would never be able to roller skate good enough to, try to play that.
Yeah, I mean, I think I'm at that stage where I'm like, am I ever going to be good enough on skates to be able to do this confidently? But it's really fun. And the group of people that I skate with, so it's a very kind of feminist sport.
Okay, yeah.
It's a really fun group of people from all different walks of life. And they're all very supportive and very like, yeah, you can do it. So it's a nice sport.
Nice. Do you do other things? I know you have 2 cats that you really enjoy as well.
Yes, I'm obsessed with my cats. So I have 2 cats, Shiro and Baloo. Yeah, I guess snuggling with cats, is that a hobby? We can include that in hobbies.
Yeah, well, it is one of mine, so I guess we can count it as a hobby. Especially, after roller derby, you probably need a bit of rest.
Exactly. So. A bit of TLC, a bit of love and care. Yes. So yeah, my 2 very cute cats. Almost as cute as your cat, Plume.
Yeah, going almost to 20 years old.
I also try to stay creative as well. I really enjoy things like music and going to concerts and painting and that kind of stuff when I find time.
Nice. How long have you been in Durham?
Just over 2.5 years. Yeah,
2.5 years. Yeah, so you're still discovering stuff there.
Yes, definitely. Yeah.
Yeah, it's nice.
Yeah, when I find time, because it's also life gets more and more busy as it goes along.
It's busy, and sometimes, especially in winter in the UK, because I live in the UK as well, I really feel, when it's dark really early, it's really cold or it's really wet. Sometimes, going out to do a sport, like, maybe not.
Right?
It's really a challenge sometimes. But
yeah, exactly. You want to be cozy on your sofa.
Exactly. But, I've had guests doing some cooking, obsessed with cooking or obsessed with. So any kind of hobby is nice. I think it's just as soon as, you get out of the science a bit, it's always nice to have your brain breathe a bit something else, especially when it gets hairs.
Yeah, exactly.
Okay, so we talked about, I think, everything. We're arriving at the end of this podcast. Thank you for sharing everything. And I like always to finish with the... I always say it's a French way, like le mot de la fin, which means like the last word. Do you want to, talk about something we didn't talk about, or come back on a subject that, you want to really strongly finish the podcast with?
Well, I was thinking about this, and I was thinking that I think I was like, what can you say about astronomy to kind of, but I was thinking, what can astronomy, I guess, offer for your listeners? And I was thinking about one concept that I really like, which was popularized by Carl Sagan, the incredible Carl Sagan, which is the idea of the cosmic calendar. And I think it ties in kind of nicely with what we were talking about before about galaxies and how they change over very long time scales, and how the universe changes very slowly over very long time scales, and also ties in a little bit with the science outreach stuff. And so, the idea of the cosmic calendar is that if you scale the entire history of the universe from the Big Bang to today, if you scale that into one human year, this can give you like a feeling of how long we've been around as humans. So basically, if the whole history of the universe were 1 year, then all of recorded human history would be less than a minute. And so it would be the last minute of the last day of the month of December.
Okay.
And the last 500 years, which is when the scientific revolution started, so with Copernicus and all that stuff, that would be the last second of this cosmic year. I think that's a really fun idea, that we've only been around for a really tiny fraction in terms of cosmic history, and that civilizations are very fragile. They've only been around for a very short time, and we should first of all protect and look after planet Earth. There's no planet B. That's another thing that astronomy teaches us, and also be a bit nicer to everyone else on this planet that we're sharing.
This is a really nice way to end the podcast. And I think it goes very well with everything that you shared during the whole episode. Thanks, Francesca, for everything you've shared. It's an amazing episode, as I thought it would be. So really, thank you.
Thank you so much for having me.
And as I said before, I'm going to put the links of what we talked about and where to reach you in the description. So if you want to discuss more with Francesca, just pop in the description of the podcast and just follow the links to follow Francesca and ask her everything you want to ask her. Thank you very much.
Thanks, Elodie. Ciao, ciao.
That's it for this episode of Under the Lab Coat. I hope you enjoyed it. Don't hesitate to rate the podcast on the platforms, to share it around, and to subscribe. Thank you!